Hello everyone. The next topic is well-formed formulas and truth tables. So what do you mean by well-formed formula? In this recording section, we will discuss about what do you mean by well-formed formula and what is the hierarchy. In the previous lecture, we had seen different types of connectives. So for those connectives, how we are going to give the priority if the formula is very lengthy. And next, how we are going to identify whether given formula is valid well-formed formula or not. And next, the corresponding truth tables. And next, some examples. So first we need to know what do you mean by well-formed formulas. Or simply we are going to write WFF. Okay. Or simply we are going to write formulas. Okay. So how we are going to define this well-formed formulas is nothing but here the main objective of this well-formed formula is nothing but syntactically correct and meaningful. And we are going to apply some formation rules. By applying rules, and we are going to check the given propositional logic is syntactically correct or not. Then how we are going to apply those rules and what are the rules that will come under this well-formed formula is. So these are the 4 corresponding rules for identifying the given formula is well-formed formula or not. Okay. And indirectly this is the recursive definition of well-formed formula. So the first rule is rule 1. Rule 1 is a statement variable standing alone is the well-formed formula. So already in our previous lecture we had seen each and every variable should be treated as some propositional statement. Okay. So if I am going to represent that propositional statement without any connectives, that is also valid well-formed formula. And the second rule, that is rule 2, is nothing but for that simple statement, if I am going to apply negation, this is also valid well-formed formula. That is the second rule. Without any other connectives. Only single connective, that is negation for atomic statement. So these are the cases for atomic statements. So simply negation can be applied for the atomic statements only. Okay. So the first 2 rules are applicable for atomic statements. Plain variable and if I am going to apply negation. So these are 2 valid well-formed formulas. And next third rule. Third rule is nothing but here just you can see here. I am considering A and B. A is one atomic statement. B is one atomic statement. If I am going to use these 2 statements. Okay. In terms of, just you can check. These are the symbolic representations already we had seen. And, or, implication, biconditional. Or simply different types of connectives. Okay. So these connectives should be used automatically for compound statements. Or simply molecular statements. Okay. So if I am going to apply connectives more than one statement, automatically that is also valid well-formed formula. If the formula satisfies first rule, second rule, third rule, automatically the given formula is said to be valid well-formed formula. These are the 3 conditions. Plain simple statement, if I am going to apply negation, if I am going to use more than one statement with the help of connectives. These are the definition for well-formed formula. And next, these are the some examples for well-formed formulas. So if I am going to observe each and every example. Okay. So the first example, second, third, fourth and fifth. In addition to your variables, connectives, we have used some parenthesis symbols. So already here I noted, just you can see here, parentheses are also used in the corresponding well-formed formulas. Parentheses. Okay. Here if I am going to observe these examples, just you can see here, negation followed by opening parenthesis, closing parenthesis. In that I had written some statement, that is P and Q. Okay. If this same representation, if I am going to write like this, negation without any parenthesis, whether these both should be equivalent or not. These two are not equivalent. For what reason we are going to say these two are not equivalent is nothing but, if I am going to consider this expression, okay, so we are getting some confusion. Either we are going to apply negation for P or for whole operation. So in that case, we should not find what is the exact truth value. If I am going to represent like this parenthesis, so automatically we are going to get some clarity. First we are going to apply conjunction operation. After that we are going to apply negation. Okay. So this is the meaning of equivalent well-formed formula. So like this I have given some examples for each and every well-formed formula. And next, these are not well-formed formulas. Okay. Just you can see here. First case, P and. So to perform conjunction operation compulsory we need to take more than one statement. But here we are having only one statement. We are not having one more statement. So we can't apply conjunction operation. So this is not valid well-formed formula. So if you are going to observe this operation, just you can see here, we are going to call this operation as implication. That is conditional statement. And that conditional statement should be used between two variables, between two statements. Okay. But here statement, one statement followed by another statement before we are using. So this is not valid case. So like this I have given some examples which are not well-formed formulas. And next here parenthesis is missing. Okay. Here also parentheses are missing. How we are going to apply the operation? Just you can see here. Three variables are there. Either we are, but we are going to get the confusion. Either we are going to apply PRQ first, then apply and or PR, Q and R. So like this we are going to get more than one convention for the given representation. So in that case we are not going to get the final accurate truth value. So in that case you are going to represent very clearly where we are going to include parentheses very clearly. In that case automatically we are going to get the final exact output. And next, here I have given why, for what reasons we are going to say these are not well-formed formulas. So if I am going to observe the first formula, just you can see here, negation. So already here I told what is the differentiation between including parentheses, without parentheses, how we are going to give the conventions. So the same logic here also applied. Just you can see here, either we are going to apply this negation operation for the whole statement or simple P. So in that case we are going to get some ambiguity. So this is not well-formed formula. So like that for different types of examples, for what reasons these are not well-formed formulas, I have given very clear description. And next, what is the hierarchy of operations and parentheses? So first, already we discussed different types of connectives. That is negation, conjunction, disjunction, conditional, biconditional. But extra what we included in our well-formed formulas? Parentheses. Okay. So that parentheses should be more higher priority. Okay. And next, second priority is negation. And third priority is conjunction and disjunction. Both are equal priority. And next conditional. And next biconditional. So this is the sequence of priority for each and every connective including parentheses in the case of well-formed formulas. And next, identification of well-formed formulas. So already some examples how we are going to find valid or not. Okay. So just you can see here the first example. You can check in-depthly P or Q. So we are going to perform the operation. And after performing this operation again we need to apply implication. For the whole formula also we are having parentheses. So this is in correct format only. So this is valid well-formed formula. Okay. So like this you have you have to check in-depthly each and every variable followed by what are the connectives that we are having, whether parentheses can be used properly or not. That you are going to check for identification of well-formed formulas. And next, truth tables. So already how we are going to find truth tables in our previous lecture for the simple statements. So here I have given in our previous lecture I have given one formula. N distinct variables if I am having, automatically the possible combinations are 2 power n. So like that, if n equals to 1. So this is the case for negation case. So how many variables? For the negation case, we are going to consider only one variable. So that is 2 power 1, 2 combinations. What are those 2 combinations? One is true and the other is false case. So and for 2 variables, that is p and q, 2 square. How many combinations that we need to generate? 4 combinations. What are those combinations? True, 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 false, false, true, false, false. So like this, we need to find what are the possible combinations in the corresponding truth tables. So this is the formula, equivalent. And next, for identifying this truth table, we are having 2 methods. Method 1 and method 2. In exam point of view, we are not going to get use method 1 and method 2, which is convenient that you are going to follow. That is enough. So just I will tell 2 methods here. So instead of taking this lengthy problem, so this is very lengthy problem. So instead of representing, if I am going to consider the simple problem, if I am going to consider, just you can see here, P R negation Q. For this simple problem, I will tell 2 methods. Okay. So from the 2 methods, just you can apply for the given example. Okay. So PR negation Q. So PR negation Q is nothing but, before going constructing truth table, first we need to find how many combinations. So how many variables that you are having? 2 variables. So 2 variables is nothing but, what is the formula? 2 power n, 2 square. So how many combinations? 4 combinations. What are those combinations? So one column is P, one column is Q. And next, what are the combinations? True, 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 false, false, true, and false, false. So these are the possible combinations if you are going to get 2 variables. Okay. Next, you have to go for the given formula. So what is the formula that we are having? Instead of writing directly P or negation Q, so first you should write negation Q. Then you have to apply OR operation. So how we are going to apply negation Q? Negation Q is nothing but simply, what is this operation? What is this connective? Not. So not is nothing but simply we are going to reverse the truth values of Q. So what are the truth values for Q? T. T should be replaced with F. F should be replaced with T. T should be replaced with F. F should be replaced with T. This is negation Q. And next we are going to write PR negation Q. So first column, third column. We have to apply what is the operation? OR operation. So what is the logic for OR operation? Here OR is nothing but disjunction. So what is the logic for disjunction operation? If both variables are false cases, then the resultant is false. Okay. So just you can check in which order? P or negation Q. Both are false. Just you can see here. In the third case, we are having false. In remaining all cases, you are going to get true only. Just you have to check, instead of checking each and every column, you have to apply what is the logic for each and every connective. Where we are having that combination, directly keep the corresponding truth value. For the remaining cases, directly the remaining what is the opposite truth value. Okay. So here for the disjunction operation, false is the result. The remaining all are true cases. Okay. So this is PR negation Q, the final resultant column. So this is the method 1 according to the formula. And what is method 2? Method 2 is nothing but, here how we are going to write? First we have to indicate very clearly P, Q. Okay. And next, what is the formula that we are having? Again you have to indicate very clearly from left to right direction. P including connective or negation Q. Okay. So like this you have to write the corresponding columns according to your formula. Okay. And next we have to write the corresponding truth values. What are the truth values? True, 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 false, false, true, false, false. So this is first step. So directly I am including 1, 1. So the meaning of this 1, 1 is nothing but, in the step 1, directly we are not applying any operations. The meaning of this representation is nothing but, still we have not applied any connective and we have not applied any connective between the statements. That is the meaning. So 1 is nothing but initial values. Okay. Next, what is the next corresponding column that you are having? P. P is nothing but already we considered in the first column. What are the truth values? T, T, F, F. Okay. And next, and after this what we are having? So directly you have to write as it is 1, because again we are considering the same values. Okay. And next, R. What is this R? Connective. So we have to apply the logic. So before apply for the logic, we are going to find negation operation. Okay. So after applying this negation operation, then we can go for pure negation Q. So before applying negation operation, first we need to write Q values as it is. What are the Q values we are having? T, F, and next T, F. As it is we are considering. So again you should include 1 only. You should include 1 only. So the meaning of this bottom indication I am representing in circle is nothing but simply those are the steps. So in the step 1, as it is, the truth values for P and Q we are considering. Then you have to apply negation. So this negation should be applied for Q or not. So just you can check in the formula. We have to apply this negation operation for Q only. It should not be applied for P. So where we are having Q? Here. So simply negation is nothing but we are going to reverse the truth values. So what are the truth values for Q? F, T, again F, T. Okay. So here you are applying what is the operation? What is the connective? That is negation. Now you have to give second. Okay. You are applying some connective on particular column. Then you have to change the step number. So 1, 1, 1 is nothing but as it is we are considering. We are not applying any connectives. Whereas 2 is nothing but we applied some connective on corresponding column. So this is the second step. So this is the negation result. Negation result. Then we have to go for the complete formula, that is P or negation Q. So where we are having P? Here in the third column. And where we are having a negation operation? In this 1, 2, 3, 4, 5, 6 in the fifth column. So between this you have to apply OR operation. So what is the logic for OR operation? Both are false. The resultant is false. So you have to check both are false. Just you can see here. Here we are having both are false. So in remaining all cases true only. Okay. So you have to assign now 3. Now the overall result column is this step 3. So like this we have to follow step by step process in bottom of the table. We have to indicate very clearly. So in the first step directly according to your formula from left to right direction including parenthesis you have to write very clearly. Okay. And what are the possible truth values you are considering directly? For those steps you have to indicate very clearly step 1 only. Where you are applying the connective. In that case you have to change the step number. Okay. So simply by seeing these numbers automatically will get some idea. That is 1, 1, 1 is nothing but we have not applied any connectives. Okay. Directly we are considering truth values. Whereas 2 is nothing but we have applied some operation. 3 is nothing but again we applied some operation. So overall formula result is in corresponding fourth column. Now this is the final result. In the exam point of view, you have to highlight that column. So regarding this method 1 and method 2, which is convenient for you, you have to follow that method. So it is not mandatory and we are not going to get the questions use first method, use second method, not like that. So these are the truth table 2 methods constructions. And next, some examples I have given, just we can practice these examples. So in this lecture what we discussed, simply what do you mean by well-formed formula? What are the rules for well-formed formula? And next, what is the hierarchy? And next, how we are going to compute truth table combinations and how we are going to find truth tables by using method 1 and method 2. So till this, it is very, very important, this construction of truth tables by using connectives. Very, very important question. Thank you. In the next class, we will see the next remaining further topics.